I like building things and I want to build more. I just put together the skeleton for a portfolio and I want to fill it up with projects. I want to make projects that are interesting, that are visual, that are fun to show off, and fun for you guys to follow along with. And to start, I think we're going to build a falling sand simulation. So this guy Jason put together a falling sand simulator, and I think it's a great place for us to start. Effectively, he has a blank canvas. Clicking, dragging will spawn sand, and it's just beautiful, visual. The color is fun, and it's just so satisfying to fill up. So this is what we have so far. We have our blank canvas, and the first thing we're going to do is we're just going to put down a square. And ta-da! We have a square. So now we need to figure out how are we going to make this square fall. So we have our square of sand, and we want it to move down. And the way that we're going to do that is through buckets. So this right here is an array. And an array is a set of buckets, and in each bucket we can put, well, anything we want. For our purposes, we are going to represent our sand as a 1 and air or not sand as a 0. And then all we need to do to make our sand fall is to take our 1 and put it in the second slot, and then put a 0 back in our first slot. And now our sand will have moved from up here to the second slot. And then when we move our sand to here, the sand will be in the third slot. So we're going to start by coding up a visualization for an array. So all we're going to do is make our array, and then we're just going to plot those different spaces, those buckets that the sand can be in. And there we go. We have our sand up at the top here, and we can see that there are empty spots for that sand to go. So now if we want to move this sand, all we have to do is update which part of our array or which bucket has the 1 in it. So let's go over what we just did. We added this new array here and we filled it with zeros. So at this point in the code, the array is filled with zeros. Then what we do is we say buckets at index 0. So the first thing is equal to 1. So then this is equal to 1. And then down here, all this does is this draws our rectangles with a fill if it does have a 1 and empty if it does not have a 1. So if we want to move our sand to the second spot, all we need to do is come in here and then change this to a 1. So we save this, we reopen our sand, and we can see that it has moved to the next spot. And then if we want to move it one more time, all we need to do is switch this over to be a 2, and now it's in the next spot. So what we want to do is have it automatically fall down each time. The other thing that we're going to need to do is we're going to eventually want to add rows for, or columns I should say, for all of these. So the first thing that we need to do to make this automatically update is we need to move some of this outside of our draw function. This draw function runs all the time, every frame, and if we are defining a new array every time, then one iteration of the draw function is going to draw it, and then we're going to come to the next iteration of the draw function, and it's going to create a brand new array. And we need to be able to persist, which is computer science words for save, the array from one iteration to the next. So all we need to do is we're going to need to move some of this code outside of our draw function and have variables outside of our draw function that our draw function can save to when this function closes. So now that this is moved outside of our draw function, everything's still working as intended, we can update our draw function to update this array on every iteration. So now we have this loop here, and this loop goes through each bucket and checks if that bucket has sand in it, set the next bucket to have the sand in it, and set the current bucket to 0. And if we pull up our falling sand and we refresh, we can see that our sand, it's falling. It's falling a little further than we'd like, but it's falling. So that is a great first step. Let's add a quick check here, and I think all we need to do to fix that is to set our buckets. Instead of checking all of these, let's stop one early. And if we do that and we refresh here, we can see that it falls and it sticks at the bottom. Do you know what this Snorlax has that our simulation does not? Snorlax is wide. We need more columns. Well, that's it. We got multiple columns now. We have our sand falling. It's beautiful. It's wonderful. And now what we can do is if we come in here, we can copy this, and then we can paste it here, and we can update one of these. So let's say we want something at 0, 2, and then maybe we'll also put one at 2, 0. That's wrong. 2, 0. And we can see we got falling sand. I mean, it's gorgeous. I don't know what more we could ask for. I guess what more we could ask for is to see them landing on each other. So if we add one here, and we put it at 1, 2, and we save, and we refresh, we can see that our sand is falling, but it appears to be falling inside of this one. Now, why might this be? So right here, we check to see, does our current bucket have sand in it? And if it does, set the bucket below me to have sand in it as well. But we don't check, does the bucket below me already have sand in it? So what we want to do is just add a quick check here. So we can say if it does have sand in it and the bucket below me does not have sand in it. So if we have sand, if the bucket below me does not have sand, then fall. And look at that. We're falling. We got sand that can fall. I mean, I don't know what more we could ask for. So the last thing that our simulation needs is a way for our sand to pile up. Right now, if we have a pixel of sand and we drop a pixel of sand on it, it'll do this. And if we drop another pixel of sand on it, it'll do this. And this looks weird. In real life, if you were to drop a bunch of sand in one spot, it would spread out and make kind of a pyramid pile. You can imagine when you dump out that bucket, it should spread out. And so the way that we can do this is we can say that when we're dropping a piece of sand, if there is a piece of sand below it, let's check to the right and to the left to see if these are filled. If these are filled, well then we can just put this on top and say, okay, there's sand here, there's sand here. We don't need to push it to the sides because there's already sand on the sides. Just add it on top. But if these are empty, then we might want to say, okay, instead of putting the sand here and making our tower even taller, move it to the side and bring it down here. Easy. So I think what we can do is we can refactor our loop here and do our checking. So remember, this is our outer loop that is saying for each column, for each row in each column, and then we say if the bucket has sand in it and the bucket below you does not, do this stuff. So I think what we can do is we can pull this out and say this is our this is our outer statement, and then we can put all of our cases inside of this loop here. So we can say if there's sand, then we go do our checks. So we'll first say if the sand below me is nothing, well then just put it in the one below me. Then we can say, and then if we do that, if we put it in the one below me, we're going to want to continue, which says don't do anything else in this loop, come back and go to the next loop. We've already dealt with this sand. But now we need to check. So if the one below me is 0, then we will put it in the one below it. If the one below me is not 0, so if there is sand below me, then we can check to the left and to the right. And to check to the left and right, all we have to do is copy this exactly and say instead of looking down 1 with that +1, we can say on the same level, we go to the left, and then we can also check on the right. I might have gotten those left and rights mixed up. I'm not exactly sure. We also might want to do the same check of on our edges, but I don't care, and I think we will just let that break for right now. So if these are 0, then we do this exact thing, but for the ones on the left and for the ones on the right. So we're saying this is in the k plus 1, which means, k minus 1, k minus 1, this is the k plus 1. Let's see how this works. So if we run our new code with a 4 high vertical line, we should expect that it'll come down and it'll place the first one on the bottom, then it'll check, then the next one will come down and say, oh, there's already something below me, let me check to the sides, and it will push out to the sides. So let's go take a look. So here we are. If we run our simulation, we can see that yes, it is checking the sides, but it seems to just push everything to the right. So we're close, but we're not quite there. Okay, so I looked a little bit further, and it seems like when we come down, we are checking to the direct left and the direct right of our current row. And say, instead of looking down 1 with that +1, we can say on the same level, we go to the left, and then we can also check on the right. And we don't want to check that. We want to check to the left and right of our row below, because we don't want to build an inverted triangle, we want to build our triangle this way. So I think if we just add a +1 here, and a +1, oh, not there, yes, an I +1 here, and then a +1 here, +1 here, and a +1 there, this should help. So if we come back to our sand simulation and we rerun it, we now see that we are getting our expected behavior of we push to the right, we push to the left, and nothing happens here. Beautiful.
The thing I want to talk about in this project is angles. Currently, our sand simulation, when we have something here and something falls, it'll put it here, it will put it here, and then it will put it here. And then let's say we get some more sand and it goes here, and here, and then we put one here, and here, and here. So we always, if a new piece of sand comes down, we always check 1 over and then place it. And then we might check 1 over here and keep adding. We're always checking 1 over and 1 down. And so we can see that our pyramid, or our stack of sand, is always going to lead to the same shape. It is always going to be 1 over and 1 up in this sort of step. And that means that we are going to have a 45-degree angle over here and over here. This is called an angle of repose, or as I like to call it, the sand piling up angle. But we can imagine that different materials might pile up at different angles. Say if we were to stack, if we were actually to pour a bunch of sand, like in real life, out, we'd probably expect it to be pretty shallow. It probably would pour way more horizontally than, say, if you stacked up, say, like a bunch of gravel, right? Gravel might stack at a much steeper angle. I don't think it could ever actually be more than 45 degrees, but who cares for that? Or say snow. Snow always goes very flat out. And so the way that we can implement this is adding some sort of depth variable. So let's say we have a depth of 1 right now. So if our depth is equal to 1, and we have a piece of sand here, and a new piece of sand falls on, we always check and say, oh, this is 1 tall, so put it to the left or to the right. And that's what gets us our nice stack here. But now say, if our depth was equal to 2, what we could do is say, okay, we have our piece of sand here, another piece of sand is falling down. And we say, okay, it's landing on a stack. Well, how tall is that stack? Well, currently the stack is only 1 tall, so we would put our sand right on top of it, making that tower that we actually wanted to avoid earlier. But now, when a new piece of sand is falling down, we say, well, how tall is the tower? And well, now the tower is 2 tall, which is equal to or greater than our depth. And so now that our tower has been built up to that height, and we see that, now we can bring a piece of sand down and put it to the side. And then the same thing on this side, we pop it down. But let's say we fill those 2 up, and we have another piece of sand coming down. Well, how tall is our tower now? Well, it's landing on a too high tower, but that tower has this base here, and we can call that a full base. And so if it has a full base, we can effectively delete that and say that now we have a 1 stack, 1 high stack, and we should put this back on top.
So I think to implement our depth, the first thing that we're going to want to do is store a So I think to implement our depth, the first thing that we're going to want to do is to store that variable of our depth. So whether it's 2, 3, 4, 5, that'll determine how tall our pile is. So we can store that up here. We'll start with having that equal to 2 so that we can check the differences. And then all we need to do down here is always check if we're going to move to the left or the right. That means that we need to have an empty space down our depth. So right now we were hard coding 1 as our depth, saying always check 1 below. But I think that if we just change these to store or to look at the bucket, instead of 1 down, it might be 2 down, it might be 3 down, it is always going to be depth down. And then if we just add some checking here to make sure that we don't go too far below the screen, so I plus depth is less than our height, and that. Then, if we pull our simulation back up, we can see that we have a steeper pile here. So this is not really that pretty of a pile. But if we change our depth here to say 1, and then we refresh, we can see that we get a much more shallow pile. If we change it to say 3, and we come back here and we refresh, we can see that we get a much taller pile. This is still kind of a gross pile because of the initialization that we have. If we just get rid of everything on another column, and we say that we only have one column here, now we can see that we get a more uniform height. So that is with a depth of 3, so we can see that it's not pushing anything down to the side. If we say change this to be 4, which is a little bit aggressive, I guess, we can see that we're getting a taller one. So I think there are 2 things that I would like to add as final polish before finishing up this project, and that is going to be adding a clicking and spawning mechanism, and that should be super simple. We just say when you click inside of a box, set that box to be a 1 rather than a 0. Currently we are just been hard coding in our sand here, but we can just say when you click in a box, figure out which box you're in, set that box to be 1. Should be pretty easy. And then right now we are always checking the right and then the left for making our pile, and I think it would be nice if we made this randomly choose between left and right so that our piles don't skew to one side. So I am going to go add that polish in, make it all pretty, and I will show you the final project when it's ready. So this right here is our final project. As you can see, I turned those array visualization lines off. I have turned the grid size way down, and I've added in the ability to spawn sand in. This is pretty fun to play with. We also have a reset button, which obviously clears the canvas. And then we have a slider here, which allows us to change that depth value and the angle in which our sand piles up in. We can turn this down and it'll make it flatter, and then we can turn it up and it will allow for steeper. So I am really happy with how this turned out as a first project in this portfolio and as a first video on this channel. So I hope everybody enjoyed, and stay tuned for more projects. Thank you.